In this question, we're given that a process occurs in which the entropy of a system increases by 125 joules per Kelvin. During the process, the energy that becomes unavailable for doing work is zero. Is this process reversible or irreversible? So we're given that the energy unavailable for doing work is equal to zero. Usually we represent this as W unavailable. And we have written this previously as T0 delta S of the universe. And usually, so we're given this is equal to zero. This is basically the amount of energy that diffuses into the universe, and it cannot go back to the initial state of the system. And it's a property of any irreversible process. So we are told that this is equal to zero, which means that none of the energy of the system is released out or diffusing out to the universe or to the surrounding. So all of the energy is just used for the processes that the system itself is undergoing, which means that we have a reversible process. And you can also think of this mathematically. If W unavailable is zero, then delta S of the universe is zero. And thus, again, we have a reversible process. In part B, we want to find the change in entropy of the surroundings. I will use our formula that delta S of the universe is zero, and then I will write this as delta S of the system plus delta S of the surrounding. This is equal to zero, so delta S of the surrounding can be written as minus delta S of the system. Now, we are told that delta S of the system is 125, so this is just minus 125 joules per Kelvin.